Okay, the next section of the book, we talk about the different types of aqueous reactions. There's 3 different types that we're going to be looking at. Precipitation reaction, in which a solid is formed from 2 ionic species, and that is shown down here. Okay, so I mixed 2 clear solutions, and I got a solid that formed. Okay, acid-base reactions, which really doesn't have a pretty picture of, because by looking at it, you can't tell that a reaction has gone forth, but you produce a salt plus water most of the time. And the last one is an oxidation-reduction reaction, which is a transfer of electrons between reactants. Okay, and so that's shown here. I have reactant A with electrons. I have reactant B that has no excess electrons. As they undergo, A gives up its electrons to B. Okay, so that's an oxidation-reduction reaction. So we're going to first focus on precipitation reaction. A precipitation is an insoluble compound. So basically in the solubility rules, every time we identify something as being insoluble, that means it formed a precipitate during the chemical reaction. What you're going to do in these problems is predict the precipitation reactions. So this is what they call an exchange reaction. So you write it as a molecular equation, and it's the exchange of 2 parts between 2 reactants. If one of the products is insoluble from the 2 soluble parts, then it is considered to be a precipitation. All right? And so this is basically probably looking just like the same solid, but it shows it a little bit better. I can't find it. Okay, I have a clear solution and I have a clear solution. Okay, so 2 soluble salt solution or aqueous solutions. But when I mix them, I produce this bright yellow cloud, which is potassium iodide. I'm sorry, I have potassium iodide as a solution and lead 2 nitrate as a solution. This precipitate is lead 2 iodide. Okay. So here is a type of reaction. Okay, so it says write the molecular reaction and the net ionic for the following aqueous reactions. What this means here is that all my reactants, unless it states otherwise, are aqueous. If no reaction occurs, write an NR after the arrow. Okay, so double exchange, what that means is, and I'll start out in blue here, is that this silver, so the first ion goes to the second ion. Okay, and what happens is it forms Ag, and the charge on the Ag, you have to know the charges here because you have to do that. The subscripts come from the charges, not from the previous thing. Okay, and I, okay, and I is a -1, so I end up with AgI plus, okay, change colors, Na and NO3. So the one that's written on the left and the reactant side is going to be written on the left on the product side because it's a positive. You always write your positive ion first. So sodium, which is a +1 charge, NO3, which happens to be a -1 charge, so it's NaNO3. So I left room to write there. Alright, so step 1 is to write the products. Step 2, balance the reaction. Okay, so I've got 1 silver, 1 silver, 1 nitrogen, 1 nitrogen, 3 oxygens, 3 oxygens, 1 sodium, 1 sodium, 1 iodide, 1 iodide. So this one didn't need to be balanced. All right, step 3, determine if either product is insoluble. So going back to the solubility rules that we learned in section 1 of this chapter. Okay, so silver is not a group 1 metal. Okay, so then I have to look at iodine. Most iodides are soluble except silver, mercury, and lead. So therefore this one forms a solid. Okay, looking here, sodium is a group 1 metal. So all group 1 metals are soluble. That's rule number 1. So this one is aqueous. So a reaction occurred because I produced a solid. Okay. So now to write the net ionic equation, now that I know that a reaction actually occurred, okay, 4 is if a reaction occurred, which in this case it did, write complete ionic equation, which is what we did in the last video. Okay, so I have Ag plus NO3 minus goes to, plus, don't ask me why, sodium plus I minus, because it tells me all my reactants are aqueous. But this being a solid, it stays together, so I have AgI plus, this one's being aqueous, so it breaks down to Na plus NO3 minus. Okay. Silver doesn't exist over here. Nitrate does, so I cancel it out. Sodium exists over here and exists over there. So step 5 is write net ionic. So I have Ag plus I minus goes to form AgI. Okay. Next one, same problem in the book, just a different number. Okay. I do the same process. I'll start with green. I've already got green. So NH4 goes with K2SO4. So NH4 is a +1 charge. SO4 is a 2 minus charge. So this becomes NH4 2 SO4. Okay. Plus, I'll change colors. Back to my blue. Nitrate and potassium, but potassium is written first, so potassium has to be written first. So it's a K plus and an NO3 minus, so plus K NO3. All right. Next, balance the reaction. I've got 1 nitrogen here and I've got 2 over here. So I need to write a 2 here. Okay. I had 2 nitrogens over here and I have 3 over here. Sorry. Alright, we don't want to start with nitrogen. Forget I said nitrogen. Nitrogen's complicated. Sorry. Hydrogen. We only have hydrogens over here. I got 4 hydrogens over here. I got 8 over here. So, yes, I put a 2 there. Okay. Oxygens are complicated, so I'm not going to do oxygens. I've got 2 potassiums here and only 1 over here. So I'm going to put a 2 there. And now let's see about my nitrogens. Okay, now I've got 2 times 1 is 2 plus 2 times 1. So I've got 4 nitrogens. I've got 2 times 2 is 2 plus 2. So I got 4 nitrogens, so that's balanced. Oxygens, I've got, or let's do sulfurs first. I got 1 sulfur here and 1 sulfur there. Oxygens, I've got 2 times 3 is 6. Plus 1 times 4 is 4 to give me 10 oxygens. I've got 4 oxygens here, plus 2 times 3 is 6 oxygens there, gives me 10 oxygens. So everything is balanced. Okay. So I balance my reaction. Erase all of it. Okay. Now, next thing is decide, did I form a precipitate? So NH4 plus is that rule number 1. As rule number 1, it doesn't matter what's attached to, it is aqueous. Okay. Potassium is group number 1, so it doesn't matter what it's attached to, it's aqueous. So if both of my products are aqueous, then this is a no reaction. And I don't need to go any further. And that is the end of this video.